So probability is defined as the chance of something happening. Well, that something that happens is called an event. Now, life is full of events, and again, with probability, we want to determine the chance of an event happening. Now, with events, we have events that are impossible, and we also have events that, well, are certain. Now, when we talk about probability, we're talking about fractions mainly, but probability deals with numbers between 0 and 1. If we have a probability, and that is a chance of an event happening of 0, that means it's impossible. It won't happen. However, a probability of 1 means the chance of that event happening is certain. Anything in between, the closer a number is to 0, the more unlikely it is to happen. The closer that probability is to 1, the more certain it is to happen. So with events, there's different kinds of events that can happen. And so when we talk about events, we can talk about what's known as a sample space. And a sample space simply is a list of things that could happen. For example, let's say that we rolled a die and flipped a coin. Well, our choices for rolling a die are 1, 2, 3, 4, 5, and 6. There are 6 events that could happen when we roll a die. Now, if we flip a coin, that coin can be heads or tails. So there's 2 events there. Now, we can combine these in the fact that if we were to roll a die and flip a coin, this is the list of possibilities. If we roll a 1, well, we could then have either heads or tails. If we roll a 2, we could also have heads or tails, and this is going to continue all the way through. Now, if we roll a die and get a certain number, and if we flip a coin and get a certain heads or tails, how many possibilities do we have? If you take a look down here, we have a total of 6 times 2, or 12 possibilities. This is an example of the fundamental counting principle. And the fundamental counting principle simply says, if I have events that are going to happen at the same time, well, there are 6 possibilities for rolling a die, times 2 possibilities for flipping a coin, so there are 12 possibilities combined. Now, this fundamental counting principle is used to do outfits that you might wear. You also will hear it at restaurants when they talk about how many combinations they have for sandwiches, let's say. For example, let's say a restaurant advertises that they have 8 types of bread. They also have 5 types of meat, and they have 10 kinds of vegetables that you can put on your sandwich. Well, if you select one in each category, you would have 8 times 5 times 10, or 400 sandwich possibilities. Now, we know that sometimes sandwiches have more than one meat or more than one vegetable on them, so that number could be even greater than that. So this is a sample space, and this shows us the fundamental counting principle. Now, let's get back to probability. Now, probability, let's take a really simple example here, and let's say we've got a bag, and that bag in it has 5. Let's say it has 5 green. Let's say marbles. And the same thing has let's say it has 3 red marbles as well. Now, in dealing with probability, a lot of times we use a P. So let's say we want the probability of picking a green marble. Well, the probability of picking a green marble is, in the bag there are 5 green out of a total of 8. And so the way probability is figured, the probability of an event is defined by the number that are possible for that event out of the total of what we're dealing with. So we had 5 green out of a total of 8 marbles, and that gave us 5/8. Probability also gives us a great time to look at our fractional skills as well. Okay, so this is an individual probability event. But now let's say that in this case we would like to do something different. Let's say we want the probability of picking a green one, and then we're going to pick a second green one. But what we're going to do is we're going to put the first green one back, and we're going to call this with replacement. And the way this works is as follows. Now, we've already established that if the probability of picking one green one is 5 out of 8. Now, if I take that green one out, and then with replacement means I'm going to put it back in the bag, well, the second time, my chance of picking a green one is also 5 out of 8. Now, what I do in this case is, this is a compound probability problem. I'm doing more than one thing at the same time. So I'm going to multiply these, and that's how you do compound probability problems. So 5/8 times 5/8 would give us 25/64, and that's the probability. Now, we could also convert this to a percent. 25 divided by 64 would give us a decimal, which we can then move 2 decimal places and change to a percent. Okay? And so in doing that, what I learned, if I calculate, is 25 divided by 64 gives me a decimal of 0.390625. Now, if I move the decimal twice, that means my percent chance of this happening is about 39%. Now, that's with replacement. And what that means is, this is a situation, since we're putting it back, where each one is independent of the other one. Again, we're putting it back with replacement. Now, let's show you the probability again of green and green. But this time we're going to pick a green item, green marble. But this time we're not going to put it back. So without replacement. Now, this situation is dependent, because the probability of pulling a green one out is 5/8. Now, because I pulled one marble out, I only have 7 marbles in the bag. And because the first one was green, I now have only 4 green marbles left to choose from. Gives me 5/8 times 4 7s. Now, using my fractional skills multiplying, I know 4 goes into 8, and 4 goes into 4 one time. And so I can get a final answer of 5/14. Doing some quick calculations, this decimal turns out to be 0.357, and it goes on quite a bit. And the chance of this happening is about 35.7%. So I have a better chance of picking 2 greens if I put the first one back in, which makes sense. Okay, so that's probability in terms of compound probability. Well, we're doing one thing and then we're doing something else at the same time. Now, we can also talk about probability in a really simple spinner example. And let's say we want the probability. Now, what we're going to do is we're going to do one event. And this time what we want is we want the probability on the spinner of an odd number. Well, on the spinner there are 3 odd numbers. out of 6 possibilities. So the chance of me getting an odd number is 1/2. But let's say this time I wanted an odd number or a 5. Well, if you'll notice that 5 is also an odd number. So I have 3 odd numbers, and 5 is one of those. And these are called overlapping events. You're doing the same thing, basically. And or means we're still only going to do it one time. So again, this is 3 out of 6, or 1/2 as well. But let's pick something that's a little bit different. Let's say we want an odd number, or we want a 6. Okay? Now, in terms of these, could these happen at the same time? Well, an odd number is not 6. 6 is not an odd number. We call these kinds of situations mutually exclusive. They're separate items. Odd and a 6 are 2 different things. So how many odd numbers do we have on the spinner? Well, we have 3. But we also could want a 6. Well, there's only one 6. So that gives us the 3 odds plus the 1 6, and that gives us a total of 4 out of the possibility of 6 items, which reduces all the way down to 2/3. Okay? Overlapping, mutually exclusive. Now, when we talk about probability, we can use probability to predict as well. For example, given a situation, let's say we go to a theme park. And at that theme park, you monitored the first 20 people through the gates. And you notice that there are 8 men and 12 women that come through. Well, the probability that the person that comes through the gates of this theme park is a woman is 12 out of 20. 20 being 8 plus 12, total of 20 people. Now that reduces nicely, taking and dividing both by 4 to 3/5. Now let's say that on this day, there are going to be 1,000 people come through the gates. How many women could we expect? Well, based on the probability of the first 20 people that have come through the gates, 3 out of 5 are going to be women. Now, if I set up what's known as a proportion, 5 is the total out of that reduced this 20 reduced to. So 1,000 is also a total. It's on the bottom. Probability, the bottom number is our big number. It's our total. So I want to find out, how many of these 1,000 people would be women. So I could cross multiply this. Gives me 3,000 is equal to 5x, and divide both sides by 5. And I would discover that 600 people out of these 1,000 would be women. Meaning the other 400 people would be men. That gives me 1,000 people total. And that's how we can use probability. Probability is used a lot by insurance companies as well to set rates based on chances of people having accidents in the past as well. Now there's one last thing that we can talk about, and that's odds. Odds is a form of probability. It's used with a colon. Not always are these set up as fractions. But odds is the chance of, and it's a favorable chance of an event happening compared to the unfavorable chance of an event happening. I'll give you an example. Let's say that we have some shapes. Okay. So I'm taking a look at these shapes here. Let's say we want the odds of selecting a triangle out of this group here. Well, how many triangles do we have? Well, we have 1, 2, 3, 4, 5. So we have 5 triangles. How many objects are not triangles? 1, 2, 3. We say the odds of selecting a triangle from this group are 5 to 3. Now, the odds of selecting a circle, well, there are 3 circles, and there are 5 objects that are not circles, and that's how we would set that up. Let's say in closing that we enter a contest, and there are 5,000 people that enter a contest. 5,000 people. What are the odds that you win? Only one person can win. Well, the odds, well, one person out of those 5,000 people will win compared to the 4,999 people who will not win. This is probability with a little touch of odds, and probability is, again, the chance of an event happening. Odds is a favorable versus unfavorable outcomes.